Shri Sathya Loka Seva Gurukulam online classes. We've been learning differentiation. In this video, we are going to learn how to differentiate such functions. What is different in this function? We know how to differentiate power functions. That is, whenever a variable is raised to a power, a constant power, right? We know how to do that. So, f dash of x will be equal to n to the power x power n minus 1. We know how to differentiate a polynomial. But now, we are going to learn how to differentiate a polynomial raised to a power constant, a constant power rather. So, here we are going to use two results that we know together and then do it. Now, for my convenience, I am going to replace 1 minus x square as u, so that my y, that is equal to f of x, becomes u power 17. Now, I can easily use this particular result to differentiate this. Now, what do I need? I need to differentiate, find the derivative of each of the following. This y or f of x is in terms of x. So, I need to find dy by dx. But I have converted my y into u. So, with u, how am I going to find the dy by dx? So, what I am going to do is, I am going to find dy by du into du by dx. So, what do I get? My du gets cancelled, I get dy by dx. So, my dy by dx is rewritten as dy by du into du by dx. This is called as the chain rule. So, what do? My y is equal to u power 17. When I have to find dy by dx, I find dy by du first, that is 17 u to the power 16, and then multiply it to du by dx. So, now how do I find du by dx? Go back to the relation u in terms of x. If I differentiate this in terms of x, I'll get du by dx. So, this is a normal polynomial which is easy for me to differentiate. 1 becomes 0, minus x square becomes minus 2x on differentiation. So, this will be rewritten as u power 16 into minus 2x. Now, u is an assumed variable. I'll put it back in terms of x. So, it's 17 into 1 minus x square into minus 2x. So, again I'll rewrite it, putting the constants on the first. So, minus into plus minus, 17 into 2, 34, monomial first and then the binomial. So, this is how I express my answer. So, the constant first, then the monomial, then the binomial, depending on number of terms, I place it. This is called as the chain rule. So, this is u power 16. So, it's 1 minus x square, the whole raised to the power 16. The whole raised to the power 16. So, what have I done here? I have used this power rule first, brought the power down, kept the base as it is, subtracted 1 from the power. So, the power rule I have applied, multiplied by, I have differentiated the base polynomial. So, in case you do it the other way around, just bring down the power and differentiate the base all put together, it goes wrong. So, according to the chain rule, we'll have to apply one rule at a time. The outermost function is the power function. So, we apply that rule first. We didn't bring down the power, reduce 1 from the power into, then the next function, the inner function is an algebraic function. It's a polynomial. Then you apply the rules of differentiation for that and you multiply and you take the product of everything. So, every time you don't need to substitute u and do it and then use this formula exclusively, but you can do it directly also without not showing your u substitution and the chain rule formula. You can directly do the differentiation, but step by step without doing any mistakes, you need to do it. So, now we'll see more sums so that you get used to it. How to differentiate a power function by Newton's power rule. So when y is equal to x power n, when you differentiate y, you get dy by dx is equal to n x power n minus 1. We also know that constant on differentiation gives a 0. So these are a few results that we have learnt in previous exercises, in the previous videos. In case you have doubts, please do revisit those videos and then start watching this. Now, in this video, we are going to learn how to differentiate a function when there is a polynomial that is raised to a variable. Meaning 2-3 results put together, how are we going to differentiate it and how are we going to apply it? Let's observe this. Here if you see, there's only one single variable, but here there is a polynomial. So how are we going to do it? First, let's rewrite it. We'll write f of x as y and write y is equal to 1 minus x squared, the whole raised to the power 17. Now, for my convenience, since if I have one variable on the base, it's easy for me to differentiate. I'm going to replace it by u. U is equal to 1 minus x squared. So, my y gets converted into u power 17. My question says differentiate with respect to x. So now we are supposed to differentiate this transformed equation with respect to x. So what happens when I differentiate with respect to x? Y on differentiation with respect to x gives me dy by dx. Now, when I differentiate this, what do? I first bring the power 17 u power 16. Now, this u is differentiated with respect to x. But here we have a third variable, that's u. Now, x on differentiation with respect to x gives me 1. Whereas, u on differentiation gives me du by dx. So, whenever you use this power rule, you bring down the power x power n minus 1 into, you always differentiate the base. X with respect to x gives you 1. So, since it's multiplied by 1, we don't explicitly write it, we write it as n x power n minus 1. Whereas here, we are differentiating a third variable with respect to x. So, any variable that is differentiated with respect to another variable will give you du by dx. And y on differentiation with respect to x will give you dy by dx. Right? Now, how do I find du by dx? I have the u relation here. Du by dx on differentiation will give me 1 on differentiation becomes 0. This with respect to x will give me minus 2x. So now let me replace dy by dx is equal to 17 u to the power 16. U is nothing but 1 minus x squared, the whole raised to the power 16 into du by dx is nothing but minus 2x. So this gives me, let me rewrite it. I've always told you that the monomials should come first before the binomial. Depending on the number of terms, you need to arrange the polynomials. So the constants, we'll put it together, minus 14, x, 1 minus x squared, the whole power 16 will be dy by dx. So what do we basically do? We first apply the first result, that is x power n. The power rule, we bring the power down, 17, 1 minus x squared, the whole power 16 into, and then we differentiate the base. That's what we do here. So, we bring down the power, reduce 1 from the power. So, first we apply this rule, the power rule, and then we differentiate the base and then multiply every result, right? Here it's 17 into 2 is 34. Sorry, not 14. So we get minus 34x into 1 minus x squared, the whole power 16. This is called as the chain rule. So one after the other, we are applying the rules of differentiation and then differentiating. Now, for your convenience, if you get too confused with too many variables, you don't need to substitute u. I'll give you a tip to do it. So when it is this, let's differentiate with respect to x. So f of x, when we differentiate, we get f dash of x is equal to. So first, whenever there is power, whole power, we need to apply the Newton's power formula, the Newton's power result here first, and then move ahead. So the rule says you bring down the power, take it as a coefficient, and reduce 1 from the power into, since the base is a polynomial, we will differentiate the base function. So 1 minus x square on differentiation will give you minus 2x. So always remember, depending on the number of terms in the polynomial, you will rearrange it. So you have minus here, 2 into 17 becomes 34, and then x into 1 minus x squared, the whole raised to the power 16 will be your f dash of x. This is called as your chain rule of differentiation. So every part of the function is getting differentiated. So first always the power rule, then the inner function. So the outermost function is first differentiated. Now what is the outermost function here? It is of the form something to the power n. So first you will use the power rule, and then you have the inner function as an algebraic function, a polynomial. Then you will use the rules of differentiating a polynomial and differentiate the base and put everything as a product of one another. So this is called as the chain rule. We'll do more sums. It will be more clear. So this is our second function that we are going to differentiate. In this, if you see, is it of the form u by v? Not actually, because there is no function, it's a constant on the top. We can rewrite this function, it becomes easier to differentiate. You can write this as y is equal to x squared plus 3x plus 1, the whole raised to the power minus 1. Now we can apply our chain rule to differentiate. So this differentiating with respect to y, with respect to x, we get dy by dx is equal to, so this is a power function. So let's first use that rule, the outermost function to be differentiated using the rule. So the power will be brought as a coefficient and 1 will be subtracted from that into, so every step you need to multiply it. So into, now the base is a polynomial, you will differentiate the base. So this will be 2x plus 3. Now once the differentiation is done, you need to arrange it in proper order and express it in the right way. So there is a negative sign outside, minus 1. The binomial comes next. And this is the next polynomial, that's a trinomial. Since the power is negative, we will put it on the denominator, making the power a positive power. We cannot reduce this further, so we'll leave it here. Hope you all understand. We'll move ahead with the next question. The next question is y is equal to cubed root of x square plus 1 the whole raised to the power 5. So again, I've always told you whenever there is surds, you can express it in the exponential form for you to have it convenient for differentiation. So 5 the whole raised to the power 1 by 3. So this can again be reduced to the form 5 by 3. So now it's easy for me to differentiate. Till now I've just rewritten the function, nothing else I've done. Now I'm going to start my differentiation. So differentiating y with respect to x. What do I do? dy by dx will be equal to, so first the outermost function is a power function. Use the rule, bring the power down, x plus 1, the whole raised to the power 5 by 3 minus 1 into, now next the inner function, that's nothing but the base, that's a polynomial. So let's differentiate that, you will get 2x. If we differentiate x square plus 1, it's 2x. Now we'll rewrite it, the constant term first, next the monomial, and 5 by 3 minus 1 is 2 by 3, x square plus 1, the whole raised to the power 2 by 3. So here it can be rewritten as 10x by 3 into x square plus 1, the whole raised to the power 2 by 3. So this is our derivative, dy by dx. Moving on to the next question. So when you observe this question, you can observe the negative part. So our first thing is to, should we convert it into positive? No, but it is in the required format, we will leave it as it is. Only the answers, when you represent the answers, it should have positive powers. With the question, we need to have it like this, wherein it is of the form something to the power n, making it easy for differentiation. So let's just move ahead with differentiation. Differentiating y with respect to x. So we have dy by dx is equal to, so the first outermost function is a power function. Let's bring the power down. Use the rule to differentiate. Then comes the base. It's 2x square plus 5x minus 3. On differentiation gives you 4x plus 5. So now we have to rewrite it, the coefficient, then the binomial, then the trinomial. But if you see, there is a negative power. So answer to be expressed using positive power. So bring it to the denominator and express it this way. So this is the final answer. Let's move ahead with the next question. So y is equal to x plus root of x square plus 8. This is of the form sum of two functions. So you know that every function has to be differentiated. That's it. So let's rewrite this because I'm having a root there. So let me first express it in the exponential form. Now let's start differentiating it. Differentiating with respect to x. So we get dy by dx is equal to x on differentiation gives you 1 plus, here there is a power function differentiated. So you bring down the power and subtract 1 from the power. Whenever you differentiate using the chain rule, you need to remember, along with treating the power, bringing it down and subtracting 1, do not differentiate the base also simultaneously. Your answer goes wrong. So first step is always to bring down the power and subtract 1, keeping the base unaltered. Into the second step, you will differentiate the base. So x square plus 8 on differentiation gives you 2x. If you write it as 2x, the whole half, 2x, the whole power minus half, the entire answer goes wrong. So this you need to be very, very vigilant about. So 2 gets cancelled because it's basically getting multiplied to each other. And then x will be going first because it's a monomial, plus 8 the whole power minus half. Now since it's a negative power, I'm going to rewrite it as x by x square plus 8 the whole power half can be used, a square root can be used instead. So this is how I'll express my final answer. That's all in this video. Thank you. Sai Ram.